All right, let's get started. Welcome, everyone. Thanks for joining this deep dive on Amazon EFS. My name is Edward Name, and I lead the product team for EFS. And joining me is Daryl Osborne, who's a solutions architect at AWS, and he leads solutions architecture for EFS. I'm really excited to be here. We have lots of content planned for this session, and we have a new feature that we released last week that we're going to give you some details on and do a little demo on as well. So excited about the session, and let's get started. The session is structured around the four phases people commonly go through when they're choosing and adopting a storage solution. So what are those phases? Well, the first phase is choosing the right storage solution. So what actually makes sense for your workload and for your application? The second is testing that solution, both functionally and for performance, and potentially optimizing your application to take advantage of the performance attributes for the storage solution that you're looking at. The third phase is ingest, and that's really moving data, moving your application data, your production data onto the solution, into the service. And then finally, there's running it, so operating it in production. And we'll walk through each of these phases during this session. And let's dive right in. So phase one, choosing the right storage solution. So there are three main things that people think about when they're choosing a storage solution. So the first is, what storage type should I choose? And different types of storage offer different interfaces, different semantics, different permissions models, different features. So really choosing what type of storage makes sense for the application that you're building or the application that you're going to be running. The second is features and performance. So what are the different aspects of the solution that are important for your workload, and how do the solutions that you're considering meet those needs? And then finally, there's economics. So what's the TCO? How much does it cost to operate this? Let's talk about each of those in turn. So generally, there are three types of storage. There's file storage, block storage, and object storage. And what's file storage? So data is stored as files. Hopefully I don't have to define what a file is. And there's a directory hierarchy that all of these files are part of, and there's particular metadata associated with each file. So in other words, your data is stored natively in a file system. And when we talk about file in the enterprise context, and we talk about it at AWS, we're really talking about shared file. So data that can be accessed by multiple servers concurrently doing some sort of workload where you need to share the data. So you can think of it almost as network-attached storage, which is a concept that's common in the on-prem world. And then we have block storage, where you have a disk or you have a set of disks attached to a single computer, and data stored in chunks called blocks. And you can think of that as local attached storage or local attached disks. And then finally, there's object storage, where your data is stored in a container called an object, and each object is identified by a unique key, and your objects are stored in a flat hierarchy. So in other words, there's not in a flat structure, so there's not a hierarchical structure behind it. And object storage provides a super simple API for putting data and getting data, and commonly that API is called over the internet. So why is file storage so popular? Three reasons. So the first is it works natively with operating systems. Operating systems are designed around file storage. File systems are the abstraction that's used for displaying data to end users, and operating systems provide APIs that allow you to work with file data from your applications. Secondly, provides shared access while providing consistency guarantees and locking functionality. So that's super useful. Both of those are super useful for distributed applications where you have multiple readers, multiple writers that are interacting with the same set of data. And you want to understand what kind of consistency you can get, and you want guarantees around that consistency. And then finally, provides a hierarchical namespace, which is just a helpful and natural way to organize data. And then another aspect to think about when you're choosing the type of storage is, what is the performance that you get with each? And on this graph, on the x-axis, we're showing latency, and on the y-axis, throughput. And you see the block storage is the lowest latency of the three. And this is a general statement about these types of storage. So generally, lowest latency is block, but it doesn't scale to the throughput that you would get from file storage or object storage. And so block is very commonly used for database applications or boot volumes where you just need access from a single server and you want the lowest possible latencies because both of those things are latency sensitive use cases. And then file generally is designed for consistent low latency because that's important for a lot of applications, but it's also designed to scale to tens of gigabytes per second of throughput. So it actually has a good mix of kind of latency and throughput, good balance of those two. And then object provides the highest level of throughput scale, but it's not designed for latency sensitive applications. And so you're all here because I assume you're at least thinking about file storage for one or more of your workloads. We launched EFS about a year and a half ago, and before EFS, if you wanted to run file storage, shared file on AWS, you basically needed to do it yourself. And so what did that setup typically look like? Well, typically you would have a mirrored setup across at least two AZs, where you'd have a primary AZ that has really the primary workload, and then you have a backup that's there for availability reasons and for data durability reasons. And then in each of these mirrored AZs, you would have a file server, like an NFS server, that's running on an EC2 instance. You'd have storage volumes that are actually storing the data, typically EBS volumes. And then you would have traffic that's moving across the AZ boundaries to replicate to your backup. And then in the backup, you'd have the file server and the volumes as well. So you had to manage all of this stuff. You had to operate the file servers and disks. You had to patch the file servers. You had to be responsible for replicating the data. You had to manage failover. So this was the before. And now we have Amazon EFS, which is our native, fully managed file service. And when we designed EFS, our core tenets were to make it simple, elastic, and scalable, on top of a foundation of high availability and high durability. So what makes it so simple? Well, it's fully managed. So there's no hardware to manage, no network to think about, no file layer to manage. And it's so simple that you can create a scalable file system that can grow to petabyte scale in a matter of seconds. And it also has very simple pricing. You simply pay for the number of bytes or for the volume of bytes that are being stored, and there's no fees beyond that. And we'll get into a little more detail on the pricing. In terms of elasticity, file systems grow and shrink automatically as you add and remove data, and there's no need to provision capacity or performance, and as I mentioned, you're paying only for what you actually use. And then EFS is designed to be super scalable. File systems can grow to petabytes of capacity. Throughput scales automatically as file systems grow. And you get, even as the file system scales, you get consistent low latencies. And in terms of scale, EFS also is designed to support thousands of concurrent connections. So you can have thousands of servers connected to the same file system. And then it's designed to be highly available and durable. So every file system object is redundantly stored across multiple availability zones. And it's a strong form of consistency. And what that allows, one thing that allows is if an AZ is offline, you're still able to access your full set of data from other AZs in the region. And so that makes EFS appropriate for production and tier 0 applications. And we designed EFS to serve the vast majority of file workloads and really covering a wide spectrum of performance needs. So from big data applications that are massively parallelized and require the highest possible throughput, where you might have tens, hundreds, thousands of EC2 instances accessing the same set of data, each one driving as much throughput as possible, to single-threaded, latency-sensitive workloads. So we really wanted to cover the spectrum. And this is probably my favorite slide in the presentation, because we launched EFS about 18 months ago, and it's just so exciting to see how customers are using EFS today for a diverse spectrum of workloads. And I won't go through all these logos, but I'll talk about a couple of the logos on the slide. So first, database backups. You have companies like JD Power and Cisco. And what they're doing is they're backing up databases. So they have databases that are on EBS volumes, and they want to back them up. And they love how EFS is completely elastic. So they don't need to worry about running out of backup space. They don't need to worry about provisioning volumes and dealing with that management side of it. They can just throw data on there, throw their backups on there, and it just grows. And as they delete the backups, it shrinks. Media and entertainment workflows. EFS has become really popular for things like transcoding and processing. And you have companies like Zynga that are using EFS with their online games. For enterprise applications, you have Atlassian using it for Jira storage. They use it for their own internal Jira deployment, and they also recommend that customers that want to deploy Jira on AWS do it on top of EFS. We have Cardinal Health, which is a global healthcare services company, and they use EFS with IBM InfoSphere. In terms of development tools, GE is using EFS for version control software, and Zend is using it for PHP applications. We have Adobe using development environments with EFS as well. And then home directories, companies like Coursera, it's an online education company. Container storage, we have Netflix, we have Here. There's actually an interesting presentation that we did yesterday. It's online, you can see the video, where Here actually talked about a different use case where they actually are using EFS to store development environment artifacts. And they're storing 1.2 million artifacts on EFS that are accessed by 1,000 users. So it's an interesting one if you're curious about that use case. Then web serving and content management. Thomson Reuters is doing a session later this week. They're talking about how they use EFS for their websites. They serve 220 million views per month. And FINRA is an organization that's using it for websites as well. Digital Relab is also here this week. They're talking about EFS for powering their vast media archive. And then we have big data and analytics workloads. So Monsanto, they have a video online about how they use EFS to power a large geospatial analytics platform. Toast, which is a point of sales company that targets the restaurant industry, uses EFS as a low-cost replacement for HDFS. And then Castora, they do retail marketing analytics, and they're using EFS for data ingestion and analytics platforms. So really a very wide variety of use cases, which is really exciting. So one aspect of features that you should think about when you're considering a storage solution is, what is a security model? And what security features do you get? So with EFS, you control network traffic using Amazon VPC security groups and network ACLs. So you can control what instances within your VPC have access to which file systems using those mechanisms. You can control file and directory access using standard POSIX permissions. You can control administrative access, so the ability to create file systems, delete file systems using IAM. And in August, we announced the ability to encrypt your data at rest using keys managed in AWS KMS, or Key Management Service. And you can access EFS from various environments. So of course, you can access it from EC2 instances in your VPC. You can access it from servers in your corporate data center over Direct Connect connections, and we'll talk a little bit about that a little later in the session. And we announced this morning, actually, that you can now access EFS from your VMware cloud on AWS software-defined data centers. So you have full access to EF resources from those environments. And about the economics. So as I mentioned, you pay one flat rate for EFS. And in US regions, that's 30 cents per gigabyte per month. And that's based on just the amount of data that you're storing. So again, it's not a provision model. It's a fully elastic model. So one question people often ask me is, how do you think about that 30 cents? Is that a good deal, or how do you think about it? So one way to think about it is to go back to what I was talking about earlier in the presentation, which is, well, if you did this on your own, what would the cost be? And so if you did this on your own, this is what we looked at before. You have a mirrored setup and two AZs, and you have your file servers, your storage volumes. So you're paying for EC2 instances that are powering your file servers, and you're paying for one in your primary AZ, one in your backup AZ. You're paying for EBS volume costs, and again, you're paying for two sets of those. And you're paying for inter-AZ data transfer costs. This is the replication traffic that's going between AZs. And so let's look at some specific numbers with that example. So for example, if you're storing 500 gigabytes of data on EFS, your cost would be $150 a month, so 500 times 30 cents. If you're doing it yourself, you'd probably provision around 600 gigs of EBS, because you're not going to provision exactly as much as you need. You're not going to completely fill your volume. So your storage costs for EBS would be $120 per month. Your server costs, your EC2 instance costs using 2 M4 X large instances would be $290 a month. And just the inter-AZ traffic for a pretty standard type of workload would be $130 a month. That comes to $540 a month. So that's one way to think about EFS's TCO and to put it into context. And EFS is available in 6 regions today, and we're actively working to get it in many, many more regions coming soon. And EFS is part of a broader set of data building blocks within AWS. So we have our core storage services. We have EFS for file. Our block storage is EBS. Object storage is S3. And our archive storage is Glacier, which is also considered object storage. And those are supported by a whole bunch of data movement tools and data movement services and data security and management tools and services. And what we announced last week that I alluded to earlier was a feature called EFS File Sync. And what EFS File Sync allows you to do is to easily and quickly move data to your EFS file systems from existing on-prem or on-cloud file systems. And it does it around 5 times faster than traditional Linux copy tools. And it does it in a highly secure way, and it does it fast, and it's super simple. So Daryl's going to talk about it a little later in this presentation, give some more details, and actually do a walkthrough of that. So let's go to the next phase, so testing and optimizing. So hopefully at this point, you've made your selection of the type of storage you want. Hopefully you've selected EFS. And now, what do you think about at this point? So when testing and optimizing, several things to think about. So the first is understanding what your architecture is going to be. So what is it going to look like deployed? The second is conducting functional testing, and the third is conducting performance testing. And if you'd like, optimizing your application to take advantage of EFS's performance attributes. So in terms of architecture and kind of deployment model, what it looks like on EFS, so here's what an EFS setup looks like. What you do when you create a file system is you create endpoints in your VPC. We call these endpoints mount targets. And an endpoint exposes an IP address and a DNS name that you use in your mount command from your Linux instances to mount the file system. And so what you can have is you have these mount targets in each of your AZs within your VPC. You can have your NFS clients, your EC2 instances, spread across AZs within that VPC, and all of them have the EFS file system mounted and are accessing them concurrently. And you manage file systems through the EFS API. There's actually not a whole lot to do in terms of management. There's not a lot of levers to pull or dials to turn. That was part of our design. So there's things like creating a file system, creating and managing these mount targets or these endpoints, deleting a file system. So all of that's exposed through the API and, of course, through the CLI, the SDK, the console. And then for functionally testing, the good news is that things should just work. EFS is standards compliant, POSIX compliant, NFS 4.0 and 4.1 compliant, and most enterprise Linux applications are designed to work with those standards. But of course, you should always test and use your actual application, use your actual workload. But not a whole lot of headaches on the functional testing front. So I'm going to turn it over to Daryl now to talk about performance and dive deep on that.
Great. Thanks, Ed. So there's 2 different performance modes available to Amazon EFS file systems when you create them. The first is general purpose. This is really the default performance mode, and it's really ideal for most applications out there. It has the lowest latency of either performance mode that we provide, and it's really the best choice for most applications and workloads. The other performance mode is Max I/O. And that's really designed for large-scale, scale-out architectures and workloads, where you need to scale out to hundreds or even thousands of instances. Virtually an unlimited amount of storage and throughput and IOPS is available using Max I/O file systems. But there is a trade-off between the two. So with GP, or general purpose mode file systems, there is a sort of a limit of 7,000 file system operations per second. So if your application requires low latency access and can live within a 7,000 file system operations per second model, general purpose mode file systems is really ideal for you. If you need to scale out to hundreds and thousands of instances where your needs are going to exceed 7,000 file system operations per second, then you may look at max I/O. Now, the trade-off here, though, is with max I/O, there's a slightly higher file system operations per second latency. So you need to really, again, as Ed mentioned, test out your application and see which file system works best for you. If you do select a general purpose mode file system, we do expose a CloudWatch metric, %IO limit, that will let you know how close you are to that 7,000 file system operations per second as a percentage. So you can monitor this. You can see where your workload sits within this, really within this threshold, and see if you need to maintain and stay with the general purpose mode file system, or possibly migrate and move your data over to a max I/O file system. So EFS is a distributed data storage design. A file system is really stored across an unconstrained number of storage servers on multiple storage servers across multiple availability zones within the region that you create your file system. It really avoids, you avoid some of the bottlenecks that are typical with, a network-attached storage device, just because of the nature of this distributed design. As a part of this, you also benefit from high availability and high durability, because again, your data is strongly consistent across multiple availability zones. So often I get asked, well, what's the difference between EFS and EBS? So I'm not going to go through this entire chart, but I just want to highlight a couple of areas. One, the throughput scale. As Ed mentioned earlier, we're able to get gigabytes and gigabytes per second throughput with a file system like Amazon EFS. Based on the previous slide, that distributed data storage design, we're able to continue to scale out and achieve very high levels of throughput and IOPS. Also, when it comes to access, EFS can be mounted to one or thousands of NFS clients, EC2 instances, or even servers on-prem over, say, a Direct Connect connection. While with EBS, you can mount a single EBS volume to a single EC2 instance. So keep in mind, though, that due to the per operation latency of a distributed storage design like EFS, overall throughput is generally increases as the average I/O size increases, since the overhead is amortized over a larger amount of data. So by I/O size here, I mean that the amount of data you're reading and writing in a single operation. There we go. EFS is designed to process high volumes of concurrent operations on a file system. You can send multiple operations in parallel to EFS using multiple threads and multiple instances. So in this graph, we held I/O size constant, but we had 10 instances, and we increased the number of threads per instance. And as you can see, as we increase the number of threads, our IOPS also increased. So again, this lends itself to this distributed data design of EFS as we can continue to scale out to larger and higher levels of throughput and IOPS. So there are a number of mount options that you can use to mount NFS systems. We do recommend sort of the default mount options when mounting EFS to an EC2 instance. We recommend Linux kernel 4 and above. And we also recommend using NFS client 4.1. One of the options that we do recommend is really the 1 megabyte read and write buffer size. But that's really one of the defaults. And all of these mount options are available. You can read about them in our documentation. So because file system workloads are typically spiky in nature, driving high levels of throughput for a short period of time, and then lower levels of throughput for the remaining of the time, we built in a burst model within EFS. Throughput is based on the size of the file system. The baseline throughput is 50 megabytes per second per terabyte of data stored. And that is the throughput that you should continuously achieve. Now you're able to burst above that up to 100 megabytes per second per terabyte of data stored when you're bursting above your baseline. So now let's talk about ingest. How do we ingest data into an EFS file system? So what do you think about? First, you want to think about where is it coming from? What is that source data set? Is it coming from maybe on-prem? Is it coming from within the cloud? These are some of the things we want to consider. Then also, we want to be able to transfer it as efficiently as possible. So what are some of the tools we can use in order to make that transfer? So generally, we can categorize where it's coming from in these 4 categories. 1, corporate data center. Typically, if you have data on-prem, you're going to be transferring this data from a corporate data center. Another, really the second category would be within the cloud from an EBS volume. Third could be other cloud storage services, maybe a third-party appliance or instance store, something within the cloud. We also have object store, Amazon S3. So when you want to ingest data from on-prem, you can mount an EFS file system over a Direct Connect connection. So what that means is you can have a server sitting in your on-prem data center with a Direct Connect, and you can issue a mount command to an EFS file system and mount that file system on that Linux server. So it allows you to then ingest data using the standard Linux copy tools that you're used to. Another way is using a third-party VPN solution, basically setting up, an example, an IPsec tunnel between your on-prem data center and your VPC, and then transferring your data over within that IPsec tunnel. Again, mounting your file system from on-prem using IP addresses of the mount target within EFS, within your VPC. And then, again, using your standard Linux copy tools to go ahead and copy that data into Amazon EFS. So you may think that these types of connections are just for migrating data into EFS. Besides migrating an entire data set, there's also conditions that allow you to possibly burst into the cloud temporarily. Moving a data set temporarily to EFS, then accessing the data from applications running within or on EC2 instances. Once your application is done processing that data, you can then easily move that data from the cloud back into your on-prem data center. This is one example. You can also use it as a backup target for backup options. So basically using EFS as a way to back up your data using native file system commands. So it's no longer on-prem and it's securely stored in the cloud on a highly available, highly durable file system. So once you've identified the source data set and you've established connectivity between your source and EFS, this could be through Direct Connect, this could be through VPN, this could be maybe just within the cloud itself, maybe from an EBS instance. You need to look at what tools are most efficient to transfer that data over into EFS. So I think most of us are familiar with rsync. rsync is a a very common tool in order to transfer files from a source to a target. One thing that I've found, I've done a lot of testing over the last year, and one thing I've found with rsync is when transferring data into EFS, it's not the best tool. rsync is single-threaded. And remember, we've been talking today about this distributed data design. A single-threaded application really doesn't take advantage of this design of EFS. rsync is also very chatty. Now, I know there are options to try to reduce that, but it is still very chatty. And during many of my tests, I've discovered that rsync really isn't the best tool to use. It really has the poorest performance of some of the tools that I evaluated. CP, or the typical Linux copy command, actually has a little better performance than rsync. It's not as chatty. But again, we also know what is CP. CP is also single-threaded. So again, you're not taking advantage of this distributed data storage design. It's only when we start looking at multi-threaded tools are we really able to get higher levels of throughput and higher levels of IOPS to EFS. One example is FP Sync. FP Sync is a tool that's included with an open source utility called FPart. It is a multi-threaded rsync. So if you're familiar with rsync and the commands, you can use FP Sync very easily. But you can get much higher throughput using FP Sync than you can rsync. Another tool that I've used is MCP. MCP is a drop-in replacement of the standard CP command or utility. It is developed from NASA. Some of the engineers over at NASA developed this, and it is open source. So you can go ahead and download it and get access to it today. But I've really found the highest level of throughput using these tools when using standard CP command and a utility called New Parallel. New Parallel is a shell tool that allows you to run a command in parallel, really allowing you to take a serial operation and running it using multiple threads. So by using New Parallel and CP, we get substantial better performance over the standard CP command. We also, if you use CPIO and FPart and New Parallel, you can get even higher levels of throughput. So what FPart does there will actually index the files that you want to copy. It will then take that index, pass it into CPIO, then using New Parallel, multiple threads will be able to basically divide that entire data set up into ranges, and each range is going to be given a certain thread, and then we're able to really get high levels of throughput into an EFS file system. So what does that look like? In some of my tests running on a C4 2XL, I had 5 gigabytes of data, 5,000 files, so averaging around 1 meg each. But some of my files were tens of kilobytes in size, and some of them were multiple gigs or multiple megabytes in size. So I ran a test. I transferred using multiple tools, these 6 tools, and these are the results that I got. So you can see, really going from, say, 11.7 megabytes per second using rsync, the exact same data set, the exact same file system on the same instance, all the way up to 93 megabytes per second when using FPart, CPIO, and New Parallel. So as Ed mentioned, last week we introduced a great new utility called EFS File Sync. So EFS File Sync is a simple, fully managed solution to transfer files into Amazon EFS using a secure, high-performance, parallel data transfer. EFS File Sync provides encryption of from your IT environment to AWS. And we see up to really 5 times the throughput of typical, of standard Linux copy tools. So again, this is a very simple, fast, secure method of efficiently migrating data from really source to destination, destination being an EFS file system. Now, there are a number of different use cases. So you can transfer it from on-prem to EFS. You can also transfer it from one EFS file system to another EFS file system. Maybe from one region to another, or from one account to another. So a lot of different use cases you can use. You can even transfer it from other in-cloud solutions to EFS. So now that we have a number of different tools or recommendations to transfer data into EFS, when do you want to use the tool? When you're within your own VPC and you need to transfer data, one option is using EFS File Sync. Another option, you can do it yourself, install these fparts and other tools, New Parallel. And now New Parallel, we did include in the Amazon Linux repo. So now if you're running Amazon Linux, you can do a very easy, yum installed Parallel, and you'll have Parallel installed on your Amazon Linux. So it's a great way to get up and running very quickly. If you're outside of your VPC, we really recommend using EFS File Sync because it really allows for a very simple setup. No more logging onto, SSHing into instances, trying to figure out installing tools. It's all done through the console. You set up your source, your target, and you basically sync the data. So let's go ahead and take a look at what this looks like. So what you're going to see here is a recording that we did on a typical EFS file sync. So you're going to see that we're going to actually install an EFS File Sync agent. In this example, I don't have my own data center, so I can't run it on my data center, so I'm actually using AWS. So I'm going to be transferring data from an EFS file system to another EFS file system. So what I do is I actually install the agent. You're actually running an AMI, and we'll go ahead and launch that within AWS. Once we get that, we will then activate it through the service, and then we'll set up the sync set. So it goes rather quickly, so let's go ahead and actually get started. Let's go back and as we can see here, we're going to go ahead and select EC2. We're going to launch this within a VPC. Very quick, it's already set up. Now that that instance is up and running, what we want to do is grab the the public IP address, and we want to put it into the configuration so that we're able to connect to the agent. Once we do that, we want to activate that agent. We give it a name, and it's activated. Now that we have that agent activated, what we want to do is we want to create a sync set. So we identify the source. This is going to be from one EFS file system. Then we identify the destination. We give this sync set a name. We create it. Once the sync set is created, what we want to do is we want to start it. Once we start it, that's going to be now pulling data from the source and moving it and copying it over to the destination. As you can see here, the status is starting. Here in a few seconds, we're going to see this start to increase. I sped it up because it does take a few minutes for the sync set to actually be created. So I sped through that in this video just for time. Now that the status has changed, we're actually copying that data. In real time, we can see that so far we've already moved, or copied 1.7 gigabytes. We'll see this in real time continuing to increase. Then at the end, we're going to see that we actually copied 21.5 gigabytes of data from one file system to another file system in about 4 minutes and 49 seconds. So we were roughly 91 megabytes per second, I think, was the throughput that we received through this. Again, very easy to set up, very secure. This is just one example of how you would use EFS File Sync. So we've already looked at when we transfer data from on-prem or within a VPC. Now, what about from Amazon S3? So definitely, we can move objects from Amazon S3 over to EFS. by just using an NFS client that has access to that bucket. Very simple, very easy. One thing you want to do, though, is you want to take advantage of parallelism when you're doing this. So while the S3CP command is by default multi-threaded, if you actually use new parallel and S3CP combined, you will actually get higher levels of throughput. I've seen in some of my examples 30 to 50% higher throughput using new parallel and S3CP than just using S3P by itself. Now in the run phase, I'm going to go ahead and turn this over to Ed.
Yep. All right, so thanks, Darrell. So when you're running your file system, there's not a whole lot that you need to think about or worry about, because it is a fully managed service. What we do provide are a couple things, though, that are important. So first is file system metrics. You can view CloudWatch metrics on file system performance. So you can take a look at the type of the level of throughput that you're driving. You can take a look at the operations per second that you're getting. You can take a look at what level of performance you're getting in your general purpose mode, and whether you should use general purpose mode or max I/O mode as a result. So a bunch of useful metrics to get a feel for how the file system is running. We also integrate with CloudTrail, so all of your API calls can be logged to CloudTrail if you enable that. And on the other side, there's also performing backups. And that's a pretty straightforward process using some standard tools and using some white papers that we have available. So these are some of the CloudWatch metrics I was referring to. And the CloudTrail API access logs that you have, you can enable as well. And again, that's for your API calls. And do you want to talk about?
Yeah, let me talk about some of the reference architectures that we've created for some very common applications out there. So WordPress, Drupal, and Magento, we have reference architectures that takes advantage of Amazon EFS as the file storage for these environments. While you can run some of these in a single server configuration, it is highly recommended if you need to scale out to actually move the file system data, say your WordPress installation directory, off of the instance itself and move it over to an Amazon EFS file system. So that really allows us to have a stateless web tier. There's no data being stored on those web instances, on those web servers. So it allows us to take advantage of, say, auto-scaling groups where you can now elastically scale your web tier up and down without worrying about, am I losing data? We also have to remember that, session information. So where does session information for WordPress, where is that stored? In cookies. So we know that that's already off the web tier. So it really lends itself to moving that file system over to EFS, moving the database data over to, say, an Amazon Aurora database instance or cluster, allows you to then take advantage of this, stateless web tier where it can automatically scale out and scale back in when you need to. We have that designed for both WordPress, for Drupal, and for Magento. These are available on our GitHub repos, where you can download. It's really a nested CloudFormation template where you can select the different parameters and deploy, say, an Elasticache cluster sitting in front of your database tier, or a CloudFront distribution that you can select the different origins and where you want to serve that up, so that some of your data is actually sitting in some of our 100+ edge locations around the globe. We also, a few months ago, launched a backup solution. This is an EFS to EFS backup solution that allows you to really automate the backup process of an EFS file system. We offer an easy-to-deploy CloudFormation template to get this environment up and running, so you are able to back up your file system and then have, again, native access to the file system because it's just sitting in a different EFS file system. All right, I'll go ahead and turn it back to Ed to wrap up our session.
Sure. So a couple things. We looked at some reference architectures. Those are available online along with feature blogs, white papers. There's a TCO calculator, a bunch of 10-minute tutorials, documentation. So a lot of really good resources available online. Just go to amazon.com/EFS. And I'm happy to announce that we have a new digital training course, or actually a series of classes on storage that's available starting now. There's deep dives on S3, EFS, EBS, storage hybrid scenarios. You can use these sessions, of course, to learn, but also to make progress towards AWS certifications as well. There's also lots going on at reInvent. We have hands-on labs. We have an EFS Spotlight lab on Thursday at 3 p.m. at the Venetian. We have storage experts, EFS experts at the AWS booth in the expo all week. And we have a bunch of sessions. Companies like SiriusXM, here, Thomson Reuters, Celgene are all talking about their EFS use cases. It's use cases like web serving, middleware applications, hybrid architectures, using EFS in dev environments. So good mix of different use cases. You can hear from the customers directly about their experience with EFS and best practices. And I know there's a bunch of sessions that you all probably want to go to across reInvent. So ones that you can't attend, these EFS sessions, they're all going to be available by video within a couple of days of the actual session happening.
So Ed, one more thing I wanted to mention that I forgot, talking about our WordPress architecture. When you're using EFS as the file system, basically when you've copied your WordPress installation directory over to EFS, you want to install OP cache. So OP cache is a bit code caching mechanism that you can install on the WordPress servers that really allows you to cache some of those PHP files. You know that with PHP scripts, it is executed and compiled each time. If you're able to cache that on the instance, you will actually have a better experience, and we highly recommend that. That is included as a part of the reference architecture. And it's actually automatically installed in the CloudFormation templates. And we have a status page per instance to make sure that, one, it is installed correctly, and two, that it's actually enabled and what your cache hits and your cache misses look like per instance.
Okay. All right. Great. So we have some time for Q&A. I think there's some mics. Yeah, looks like there's some mics over there. So.
Yeah, so make your way to one of the mics in the aisles so that we can hear.
Can I go?
Yes, please, go ahead.
2 questions about features. Number 1, do you plan on supporting Kerberos mount options in the future? And number 2, do you plan on adding snapshots as a feature?
So we don't generally talk about roadmap. Those are both features that customers have asked us for, and we're honestly balancing across a number of requests. So that's all I can really say. For backups, I would say take a look at the CloudFormation templates, the white paper that Daryl was referring to. It does make it pretty simple. So hopefully that helps. Thanks.
You can also use native. It is a file system, so you can use native backup solutions and applications you run today with EFS.
Yep. So let's go to the mic over here.
Is there any way to back it up to S3?
Yeah. So there are a number of third-party backup solutions today that back up natively to Amazon S3. So yes, you can using third-party solutions.
Okay, but the AWS Sync doesn't do it.
It does not, no.
So when you will be supporting encryption in transit?
So again, we generally don't comment on roadmap. Today we support encryption of data at rest. Encryption in transit is something that we're exploring along with other features.
Or is it in your roadmap, or it's not there at all?
Is it, sorry?
Is it in your roadmap, or it's not there?
It's something that we're looking at. That's what I can say.
Okay,
Yes.
thanks.
Thanks. Yes, please.
So SMB, any support for that? Can you answer in a general term?
We know that Windows support is important, so I will leave it at that.
My developers won't be happy with that.
Yes,
Do you have schedule for Tokyo region?
Well, so we're in 6 regions now. We're not in Tokyo. I can't again. I know these are a lot of questions about when and what, but a lot of these features are things that we are looking at. We're hearing the feedback. So I can't comment specifically on that, but we do plan to be in almost all regions as quickly as possible.
Okay, thank you.
Thanks. Yes, please.
So we do a lot of VPC peering and mount endpoint. The way it is implemented in EFS is very different from the way RDS are accessible from our on-prem. We have Direct Connect and all other communication technologies. So the issue is that the round robin, and we have to mount using IP addresses at times. And what is the correct way of doing this type of implementation? Does it support VPC peering really or not?
VPC pairing does not work with EFS. I'd love to, maybe we can come offline, we can talk a little bit more about the specifics of what you're trying to do, so we can talk about it, but we don't support VPC pairing, but there might be other things that you could do. Just need to get a little more detail on what you're trying to do. So if you're free afterwards, please feel free to stop by. Yes, please.
So I think in the demo you showed that there is a option of setting up the file sync using the console, the AWS console. Is there a CLI version of it that can be used?
Yeah, so today it's available only through the console. So you would have to, launch the agent from the console, and then, or at least download the ESX image from the console to your on-prem. Go ahead and get that set up. Start create the sync set and start it all through the console. We're looking at, do we want to go to an API, a CLI? It's something that we're evaluating.
So is it possible also to, I know that from EBS we can copy to EFS, but is it possible to copy from EFS to EBS also using that?
Oh,
not using that tool.
EFS
No.
File Sync? It is the destination will need to be an EFS file system. It is a file sync to ingest data into EFS.
Okay, thanks.
Yeah.
Please.
So on one of the early slides, it showed a couple companies that were using this for home folders. How does that work with, does that work with, say, Windows 7, Windows 10 desktops, or are they those Linux environments?
Those are Linux environments.
Okay.
Currently, you can't mount from Windows, so Linux. Yeah. Yes, please.
Yeah, quick one. I thought I heard we can mount S3 volumes onto Linux systems. Am I getting confused with EFS?
No, so S3 is accessed through the S3 API. EFS is what would allow you to mount as a file system.
Okay, so the S3 volumes cannot be mounted like EFS?
That's correct.
Okay,
yep.
Got it.
Yeah, so I'm wondering about the new feature where you allows the encryption with a key in KMS. Can I bring can I have a key that was created by me as opposed to service default key?
Yes, so we do support custom CMKs.
Okay.
It is all run through the AWS KMS service, but you import a key into KMS.
Yeah.
You can then allow that CMK to be used for Amazon EFS file systems to use to encrypt your files.
Okay. So yeah, so I got that part. But the second part is what's the implication when you have to do backup and sync to a different region? The key may or may not be. I'm sure actually that wouldn't be available anymore, right? If the file was synced to a different region or is a copy to a.
So what you would do is you would if you have a file system in another region, that would be encrypted with a different key. So the file sync your data will get decrypted.
Okay, when you copy it over, it's actually automatically get wrapped with a different key?
Yep.
Okay, thanks.
Sure. Yes, please.
Just a short question on that throughput graph that you had. where does it end? So you went up through a specific number, and what's the highest number of IOPS that you have been generating in EFS?
Yeah, so there's actually no upper bound. So it really depends on kind of how you're distributing your requests. If you're distributing it across tens, hundreds, thousands of instances, each of those is able to drive a certain amount of throughput. There's really no cap to it. There's a soft limit of 3 gigabytes per second, but that's something that we can raise. So beyond that, there's no limit.
Okay, that's very interesting. Thanks.
Sure.
Yeah, EFS has certain limits in terms of how many files we can open per instance and per process. So are those hard limits, or we have approaches where we can work around them?
Those are hard limits.
Okay.
It would be great to maybe afterwards understand what limits you're running into, because it would just be good to hear that, but those are hard.
Okay. So you're not talking about the roadmap, but do you get demand for EFS access from Lambda functions?
It is something we've had customers asking us for, yes.
All right.
So I will +1 that. Thanks. Could you explain the correlation between the 7K IOPS versus the throughput? There's an IOP, there's a number of IOPS limit, and then there's the total throughput that you have in terms of operations.
Yeah.
File system operations versus total throughput.
Yeah. So in general purpose mode, the cap is the operations per second. So the level of throughput you can drive really depends on the I/O size that you're driving. So there's no real throughput limit, I would say, as a result, but you do have this operations per second. So in practical terms, there will be a limit. Just depends on the I/O size that you're using.
Okay, so for large file systems which have a lot of metadata operations, which counts against the 7K IOPS, that's your limit.
That's correct.
Right.
Yes.
Okay.
Yep.
I see.
For general purpose mode file systems. So you do have the option of creating a file system as max I/O, and then you don't have that sort of upper boundary. You're able to extend beyond 7,000 file system operations per second for max I/O file systems.
I see. So is the typical throughput limit the instance type, the client side?
Well, not really, because you can access it from multiple instances as well. Right. So there will be a per instance limit that you'll run into, but in aggregate, you can have thousands of instances, and so each of those can drive independently, and so your aggregate throughput can keep growing.
I see. Okay. Thanks.
Sure.
So we use EFS as shared storage for web servers, but where typically the amount of storage is quite small. And the only way we can get enough performance through EFS is to create a load of dummy data to increase the amount of storage and therefore get better throughput. I just wondered if are you ever going to separate out throughput from the amount of storage? So just have options of improving throughput without increasing storage.
Yeah, so it's a feature that we've heard some customers asking us for. For most workloads, the amount of throughput you get is adequate, but there are ones where you might have a very small amount of data, or you might just need a really high level of throughput. So today the recommendation is pad your file system, but we continue to get feedback about are there other options, and so we're looking at those.
Thanks.
Yeah, I just want to echo his comments, because we did the same thing. We had a script that generated the dummy data to make sure I had to burst the code.
Right.
So we really need some solution on this one.
Okay, understood. Thanks.
So one thing that I've done to help customers in this situation is that I have a CloudFormation template that will create a file system, and you can identify how much dummy data you want to put in. So it's something that you don't have to sort of manage yourself. You launch the CloudFormation template, you can create the file system or identify an existing file system, then identify how much dummy data you want to add, and then it'll automatically spin up an auto-scaling group, DD that data into a directory, and then it's done. So while we know it's not ideal, it's something to help you sort of overcome that burden.
Okay. Any other questions? We'll also be available up here for a couple of minutes if people have other questions. But thank you all. Thanks a lot.
Thanks.